So like I was saying, the big data, this is the idea that we have so many data around. So your phone is generating data, everyone is generating data, the clinic, and so many other sources of data. However, so machine learning, before the advent of machine learning, data science has been in existence, but we are often done using statistical method. However, there's the challenge that for you to use statistical method on your data, the data need to be frozen. It cannot be moving, it cannot be changing. We all know that. The data must be frozen and stored somewhere. Then you can use your statistical method to analyze the data. However, with changing system, now we are generating huge data. There's no time. And we also have information that needs to be processed as soon as possible. And that is why one of the characteristics of big data is what we call velocity. Velocity. That is, it's a moving data. Imagine someone is traveling, he got to a particular city, Google needs to tap his data and alert. This guy is traveling, is now in city A. You immediately start seeing companies, markets, they start sending a kind of an advert to that person. Maybe you are in FCT or a capital city of a particular country. You start getting alert. There's a particular promotion going on in one supermarket. They need to do that immediately. If they wait for more than a few minutes, you will pass that city, you go to another city, that information becomes obsolete, useless. So that is why the statistical method became a kind of insufficient to model big data. Hence, they found out that with machine learning, either your data is fixed or it's moving, it has the capability to model the data, predict and do the recommendation, whatever you want to use as soon as possible without any delay. This is why, like I said, machine learning is becoming like the most important under artificial intelligence, because even other aspects of AI cannot be really practiced to the core or properly in this age without using machine learning. And this is the core that we're going to be talking more about as we move on. Now, we said be motivated. Furthermore, some of the motivation that we should come in for, both the academics, the students, the entrepreneurs, workers, no matter where you are working, who you are, you, one way or the other, needs to use machine learning. Otherwise, we might be left behind in whatever we are doing. I said ML is becoming everywhere, ubiquitous in science, talk of science, engineering, and beyond. You always find it there. You want to do anything really great in science, engineering, and beyond, machine learning will have to come to play. It is one of the hottest topics in industry today. Everyone is talking about it. They talk about the fourth or fifth industrial revolution, and this is AI-driven revolution, industrial revolution. And machine learning is at the core of it. We have multidisciplinary research based on ML is taking over academics and industrial R&D. R&D means research and development, which is now common in industry. In those days, when you study PhD, they say, oh, your study is too much. You can't get a job in industry anymore. That is old age. Now, some of the top researchers are being taken over by industries because they know the power of research. If you don't do research, your competitor will overtake you. And one of the leading means of doing this research these days is becoming multidisciplinary, aided by artificial intelligence. That's why you see a lot of research papers for academics among us. You see a lot of research papers. You do your experiment in the laboratory, well done experiment, excellent experiment. You see the editorial team trying to give flimsy excuses here and there. Why don't you do this? Just add a little bit of machine learning analytics to it. Use machine learning to process your data after you have done what you actually experimented, and come and see how, at the speed at which the editorial team will quickly pick it up. Something we've demonstrated with several of our students, our colleagues, is in chemical engineering, civil engineering. We have seen people submitted paper to topmost journal in their field, excellent work. The editor rejected the paper. He decided to use machine learning to analyze the same data. And within a few weeks, the same journals accepted it. So what I'm saying in essence is, even in the research world, in the academics, we can't run away from machine learning anymore. If we really want to be very relevant to what the industry are looking for, what the journal house, the editorial teams are looking for, so to the academics, we should be motivated to work towards achieving or learning more about machine learning. And it is very, very straightforward and simple, as we are going to see. Majority of advertised jobs are linked to machine learning AI directly or indirectly. To the job seekers, to our youth, to the undergraduate, postgraduate, and those hoping to go to the industry or job markets, we're still gonna give us that one later on when we talk about the statistics. The statistics is very staring in the face that majority of the jobs today, is in any country in the world, majority of jobs are targeting AI. Just search it. You see ML engineer, data analyst, data engineer, data science, data scientist, several jobs are linked to them. Even jobs that has nothing to do with AI, they say a knowledge of AI is an advantage. Of recent, we have seen some of the top universities that are now making it compulsory that all students must be made to offer machine learning as a course. Before, it used to be GST, General Studies, with computer science as a compulsory course. You have to learn basic of computer science. The world is going beyond that now. What people are making compulsory is that everybody must know about machine learning and AI, because this is what is expected to drive the current industrial revolution that is already on the way. So we said this class should give us the basic foundation for applying ML and developing new ideas on how can you use it in various areas of specialization. Of course, I always emphasize ethical usage. That is, as machine learning is incredibly becoming very powerful, of course, it can also significantly unintendedly be used for bad things. So either for targeting people, for crime, excluding people, misusing a host of others, except in fact, we hope that it doesn't really even lead to, it doesn't end up in the hands of people who want to use it for bad weapon. So because it could be disastrous, as we are going to see some of the attributes of AI. So the focus should be on the beneficial aspect of it while avoiding negative usage. That is why I said this is what I refer to as the ethical predictive solution. There are so many predictive solutions we can get involved in to benefit humanity, to possibly save life, and host of other advantages to prevent company from folding up. Imagine now startup is becoming the order of the day, and it's necessary. You need to have startup. Rather than look for someone to give you a job, think of how you can create job. This is what is happening all over the world. The issue is when you have startups, can't we have a system that can monitor these startups to prevent them from folding up? Imagine a startup that has started. We try to have a machine learning system that can predict if a startup is going to fold up. We can do that so that the government can come into rescue of such a company to prevent it from folding up, because when such company folds up, some citizens are going to lose their jobs. We don't want this. We can use machine learning in this kind of positive solutions and to myriads of problems we might be facing. Now moving to the AI. When we talk of machine learning, so these are a few quotes about machine learning. So the first guy that talked about machine learning to refer to us was Bill Gates, the chairman of Microsoft in the past. You all know him. He said a breakthrough in machine learning will be worth 10 Microsofts. That if there's a single breakthrough in machine learning, it will be worth 10 Microsofts. We can imagine what is the meaning of this. A single breakthrough will be worth 10 Microsofts. I personally say this is an understatement. A single breakthrough in machine learning can actually worth thousands, if not millions of Microsoft with the way things are going. So an host of other machine learning is the hot new thing. It's a matter of machine learning. But the one we are going to pick and talk more about, and I like to really make as a kind of guide for all of us, is machine learning is the next internet. It was made by Tony Tita, the former director of DARPA. What is the meaning? When you say machine learning is the next internet, it means we all know what is internet. What happened to internet? What did the internet do to us, to our system, the way we do things? Internet changed the way we do everything. Let's start from our banking system. Before you want to transfer money, well, you know what it entails. But now with internet, right on your phone, you can transfer money, you can buy things. When I was in university as undergraduates of computer science, we used to teach e-commerce, but it was theoretical because we didn't see it practically. How can you sell things online? Things you don't see, you don't have shops. But today, some of the biggest, retailers, wholesalers, they are online. Some of them don't even have physical shops. They sell on your behalf and they make a lot of money. That is internet. So today, look at your banking. You go to some bank, you have only maybe 2-3 staffs, because even deposit, you need to deposit. You don't need anybody. You go to machine, you go to the ATM machine. You want to withdraw money, ATM machine. Everything has changed. In the past, if there's a news from your village, you want to communicate your brother who possibly outside the country or even in another city, you either travel to meet him or you send letter that will take maybe weeks or months. But today, somebody outside the country will get information of what is happening in another village before you, that you are sleeping in that village, get to know. That is internet. It changed the way we do everything. So when somebody says machine learning is the next internet, what that should tell us is the next disruptive technology, that it could be positive, it could be negative, that is going to change the way we do things in the world, just like the way internet changed our life, is going to be machine learning. And it's already happening. It is already happening. So that is why people need to reskill. The way things are going to be done are going to be totally different as we move on the way. Having said that, the quotes. Now, what is machine learning? Let's make it very snappy. We say machine learning is automating the automation. Let's get this right. Automating the automation. Automating the automation. The meaning is, what we do in computing is, when you have a manual system, the manual system, we convert it to computerized system. I remember my undergraduate projects. So our bursary section then used to collect money from students for the school fees and they write it in a ledger. So I proposed that I need to computerize that system. So I transfer it from being manual to becoming computer-based. That is what we call automation. That's the meaning of automation. We used to do that in computing since long time. However, machine learning is now saying that automation, we need to automate it again. We need to automate that process itself. And that is what machine learning is telling us. You see, instead of writing software, we want that act of writing software to be made automatic again. How are we going to do it? So getting computers to program themselves, that's the meaning of automating the automation. We want computers to program themselves without human intervention, either because we don't trust human beings or because the software is difficult to write. And as a matter of fact, writing software is the bottleneck, a very big bottleneck. And that was why we had software engineering, because software suffer a lot of problems. If you notice, every few months, hardwares are being produced, but software is not like that. Maybe you have Pentium 4. After that, we have Core 2 Dual Core, i3, i5, i7. Within every few months, you have new hardware being out. But the big Microsoft, it took Microsoft how many years to develop Vista? If you remember Vista, that was an operating system called Vista. Vista. It took Microsoft how many years to produce Vista? After producing that Vista, after a few months, they realized there are major problems. They had to quickly produce Windows Me. If you remember the story, they now gave people opportunity to transfer for free. You migrate from Vista to Windows Me because they noticed serious mistake, serious error, serious bugs in the Vista they produce. This is what we call software crisis. That is the rate at which hardware is developing, software is done developing at the same rate, because it's not easy to build a software. It takes time. Even after taking a lot of time, you don't guarantee it's not going to have bugs. This is why we said writing software is the bottleneck. Now, how are we going to write a software that will write a software by itself again? Even to write ordinary software was difficult. In the past, some people, they try in software engineering to write software that will automatically generate your specification document and convert it to a code. But it never worked. But today, machine learning says, let the data do the work. Let the data do the work. And that is why machine learning is unique. And this is what we're going to be introducing ourselves to. That we can actually automate the act of writing software or computerizing a system by just getting the data. And the good news is data is available everywhere, wasting away. So we can easily use it to achieve our aim. So this is what we call traditional programming. The one I mentioned. I write a program, then I bring in the data to the computer, and then it generates output. This is what we have in classical programming, traditional programming. Machine learning is now saying it's a disruptive technology. It's saying, no, this is difficult because writing this program is a big issue. If Microsoft cannot guarantee getting bug-free software, then how do we expect it's even a small firm to get together? So machine learning said, just give us data, which is very available. You can easily get it there everywhere. The data is wasting away, by the way. Give me the output of that data. For example, last year when it rained, what are the attributes in the sky? Give us. Does it rain that day? Yeah, it's rain that day. Okay, give us that data. Give us another data of another day. What are the data for that day? What is the humidity? What is the temperature? Does it rain that day? No, it doesn't rain. Give me those data and the output of this data. Give me data, give me the output of that data. Then the computer will generate a program for you automatically. You see, it already transformed. This is what we call machine learning. So instead of wasting time to write program, and that's why I used to tell some of my students, as a software engineering student, you all need to become machine learning engineer. You're not going to lose your job as a software engineer. In fact, a lot of machine learning engineers have been requested. But at a point in time, ordinary software engineer might need to give way for automation because machine learning will take over. That is why any software engineer needs to think of, okay, how can I become machine learning engineer? So that you can actually develop, because this computer here, as I told you, we have data and output to generate program. There is some A that is going to be used to generate that used stuff. That's what we call algorithm. Algorithm, we are going to discuss them. There's going to be algorithm here that's going to be guiding the system, how you can convert data and output to become a program. It doesn't write program, but then the algorithm will guide you and the system will generate this program. So this is the shift in paradigms that machine learning represents. Then the question that comes is, what I've just said, how do you want to generate program from data and output? Is it magic? No, it's not a magic. It's more like gardening. So for those people who know gardening, so you plant something at the back of your house, you plant it at a point in time, it becomes very interesting to see like this. Something must have gone in there. The seeds, you plant the seed is the algorithm. Often you don't see it. It's hidden. Once you plant the seed, it's inside, under it. Even by the time the plant germinates, in most cases, you don't see the seed also, actually. So that is algorithm. It's always lying there. It's inside this computer there, controlling the computer, how it's going to generate the program. That is the seed. So without a good seed, then you might not be able to get any plant out. So algorithm is very important. We'll talk about that one later on, inshallah. We have the nutrients. Nutrient, you know the importance of nutrient. You need to provide, maybe if the land is not fertile, there's some naturally fertile land. Good, you have the nutrient enough. Nutrient is data. So if your plant is planted good in a very better way, but the land is barren, it's not fertile, maybe you need fertilizer. If you don't have the correct fertilizer, you don't get good result. That is data. That is data. In fact, in machine learning, data is very important. We are coming back to that. That's why we always be mentioning, let me mention it from here. Let the data speak. This is my own personal principle on this. That is, you let the data speak. The data will determine how much of good output or good result you are going to get. Then you, as the machine learning engineer, you are the gardener. You are the one to make sure you use the correct seed, which is algorithm. You are the one to make sure you use the correct data, which is nutrient. You use the correct nutrient as a gardener. That is the machine learning engineer, the developer. You are the one that is the researcher. You want to use machine learning for your work. Plants is the outcome. You know, eat the right nutrient and a correct gardener. You don't get a fake gardener who is going to spoil your farm. You're going to laugh at the end of the day because you're going to have hopefully a very good plant, which is the program that we're talking about. That's why I say automating the automation. Now, briefly, we say, what is machine learning? We say machine learning is any process by which a system improves performance from experience. So you improve performance from experience. A more comprehensive one says machine learning is the study of algorithms that improve their performance, P, at some task, T, with experience, E, which means a well-defined task is given that P, T, and E. They depend on the performance. You want to improve the performance over time at time T and also with experience E. This experience actually comes from the data. See, what kind of data do you have? Do you have a rich data or otherwise? So we said the goal of machine learning is to build computer systems that can adapt and learn from their experience. See, we want to build a computer system that can adapt and learn from experience. So from data available in the past, we can predict what's going to happen in the future. We say machine learning algorithms discover the relationship between the variables of a system. Let's pay attention to this, very important. The variables of the system are input, output, and hidden. I told you before, we used to keep computer input, and then it used to generate the output. But there's a hidden information that we don't know, the hidden. What is the relationship between the input and the output? So we can decide this hidden relationship from direct samples of the system. So you give us whole data set. As a lecturer in the university, do you have data of your previous student who sat for your exams? Give us the data so we can develop a machine learning system that can predict if the student is going to fail or not. So we gather data from previous students. So what was the age of the student, in what department, what was the score of the student in the midterm exam, then what was the final exam. Based on those previous results, we can use it to develop and predict if the present student will pass or will fail. The same thing in medical areas and so many other applications as we are going to have. So this is a generic system for machine learning. This is the inputs. This is the inputs. And then this is the hidden relationship. We call it H. Later, we are going to call this H hypothesis function. Okay, we're going to call it hypothesis function. Yeah, hypothesis function. So, and then Y is the output. Usually we know the X, the input. We also know the Y because the data is in the past. It has happened. The last time it rained, what are the characteristics of the rain? You document those characteristics. Does it rain that day? Yes, it rained. Second day, what are the attributes in the sky? The temperature, the humidity. Does it rain that day? No, it doesn't rain. So we gather those inputs, corresponding outputs, we know them. Then we want to find out what is the relationship that we can build so that if it is successfully built, we just take out this hidden relationship, which is now the hypothesis function. So tomorrow or next year, we want to predict if there's going to be rain. Just give us the state of stuff in the atmosphere. What is the humidity score? What is the temperature outside there? And other parameters that can determine if there's going to be rain or not. Since we already have the hypothesis function H that is performing well, we use that hypothesis function to predict if it's going to be rain, if it's going to rain or otherwise. And the system is very common these days. Even cyclone and other disasters are being predicted with very high accuracy. Of course, there is always room for error, depending on the kind of algorithm you have used and how rigorous the work that has been put into it. Now we move to the machine learning paradigms. So in machine learning, what are the types of machine learning? So the first one is called association rule. Association rules, which is also called basket analysis. So this is where we use probability system to check. For example, P of Y given X is probability that somebody who buys X also buys Y, where X and Y are products and services. For example, the P of chips given biscuit is 0.7. So we use association rule to see in the marketplace, in the supermarket, this thing I use a lot. Sometimes you go to some supermarkets, you see they change this location of their goods. They spend a lot of money to do this, by the way, where you have, maybe you used to have laptop, they change the position. Where you used to have laptop bag, they change the position. Because the last month's analysis of their market, basket analysis, has analyzed the customers, the pattern of purchase. So when they notice that anyone who purchased an item A, when they notice that anyone who purchased item A always purchase item B. For example, when you purchase Pampers, you also purchase baby milk. They noticed several people purchased Pampers and baby milk last month. The next month, they are going to rearrange their shops so that they make sure that they put Pampers at the beginning of the mall, shopping mall, and they put baby milk at the end of the mall. They won't put them together. Why? Because they want you to pick baby milk here, or Pampers, whichever one is put here. Let's say Pampers here. So you need to look for the baby milk, which is in the other side of the mall. So while you are moving around, you will be seeing other things on the way. You'll be picking them. If you are very much financially thrifty, your children might not be that way. So they will pick some things on the way. Dad, I want this. Mom, I want this. So before you get finally to what you are looking for, your shopping cart is already getting full. That is the essence of basket analysis. They want to know your purchasing pattern. This is one of the aspects of machine learning. So like I was saying, in the basket analysis, one other possibility is this. Maybe they notice that there's an item A, and okay, we have few C. Let's say that an item C and item D. They notice that throughout last month or 2 months, no one purchased these items. They notice that no one is purchasing these items. What they try to do, this next month, they're going to do, after basket analysis indicated that people really purchase this item. So what they're going to do is they will put them together, buy C and get D for free. Buy C and get D for free. They make promotional sales because C used to be sold for maybe $10, for example, and D used to go for like $5 before. They'll make the two to become $12. Buy C for $12 and get D for free because they knew that D was going to expire on their markets. This is one way they use basket analysis. This is one aspect of machine learning. The second aspect, you can see I put it in code. This is what is going to concern us most. We're going to discuss next lecture day, inshallah. And that is going to be the supervised learning. What is supervised learning? Supervised learning is we learn under the supervision of a teacher. When you have your data having inputs and also having outputs. So we call it supervised learning. So it has input and it also has outputs. And there are two types of supervised learning. We have the classification and regression. In classification, for example, we want to predict, let's say, if somebody, the email coming to your email, is it spam or not spam? That is classification. Somebody applying for a loan in a bank, the bank run their machine learning system to see, should we give him a loan or not? We want to predict if a patient is going to die from a sickness or not. These are called classification problem. For the regression, this is when, for the regression, this is when we are trying to predict the actual values. I want to predict the score of my student in the exam, the actual mark. I want to predict the stock market. What's going to be the credits, the temperature for tomorrow? These are, you want to predict continuous values. This is what we call supervised learning. So we're going to discuss this more in details when we meet next time, inshallah. On the unsupervised learning, it's a little to be more challenging because here we don't have the output. Either the output is missing, or we don't get the information, or the information gotten is not complete. So in this case, we still need to model it. Take for instance, we have some data for rain. We have humidity. We all experience rain. That's why we are using this example. We have humidity. We have temperature for day 1, day 2, day 3, day 4. But the output, does it rain on day 1? We forgot. Someone was supposed to write it down. He didn't write it down. Either he forgot or something went wrong, or someone mistakenly deleted the data. We have the data for day 1, day 2, day 3, day 4, last 2, 3 years data. But we didn't know, maybe it was raining on day 1 or it was not raining on day 2. But we knew that this data, there are some days that it rained, there are some other days it doesn't rain. In that case, we use what we call clustering to try to understand this data, and we can partition them into 2. We study the data itself. We don't have the output for it. So we use the clustering example to see, okay, maybe it should belong to this or it doesn't belong to this. The same example goes, or maybe in an hospital, we want to predict diabetes patient. Is it diabetes? Is it not diabetes? We get a lot of medical tests for both healthy patient and the sick patient. But sometimes the output is lost. We don't know it's diabetes. We don't know it's not diabetes from this data, but we know these are data for patient. All hopes are not lost. We use unsupervised learning to deal with such a system. But I must tell you, it is not that very easy. It is a problem we don't pray to face, by the way, because you cannot guarantee that the output is going to be excellent. But later I'll tell you other smart way that we can benefit from unsupervised learning. And the second to the last, before we stop, is semi-supervised learning. It's in between the two. You have some data that are labeled and you have some data that are unlabeled. You have labeled data, unlabeled data. That is, in rain example, for day 1, we know it is raining. For day 2, we don't know if it is raining or not. For day 3, we know it is raining. For day 4, we didn't know. They are mixed together. We use semi-supervised, like co-training, like active learning, where you have interactive supervised learning, as the case may be. And also, finally, we have the reinforcement learning, where learning a policy or a sequence of outputs. Policy could be positive, negative, punishment, or extinction. You allow a system to do something and you reward it based on the outcome. If the outcome is correct, then the reward is going to be positive. You can compensate it. This is called reinforcement learning. You reinforce that behavior. It's like a baby who performed very excellently well in his education or her education. You give some gifts so they can continue to do that. On the other way around, there's another baby that was making too much trouble. You try to correct him. You can withdraw. We can withhold the chocolate for that day. That is negative. You try to withdraw so that you can learn that what you have done is not correct. This is called reinforcement learning. You try to reinforce the habit or the capability of that system. So because of our time, I think this is where we're going to call it a day. So we're going to give a little time for questions. As we have stated, I want to believe our team of administrators are already taking note of your questions. Don't worry, the questions will be attended to, if not here, but rather at appropriate time later, as we've announced at the beginning. So maybe the admin also can remind us about the principle, because I can see a lot of people join after the lecture have started. Thank you all for listening. So we're going to stop here and continue tomorrow on the rest of the system.